Hi, this is Rohan with a new episode of 2 by 2. A big welcome to all of our new listeners on the Ken's apps and on Apple Podcasts. It's one thing to launch a new premium podcast, it's quite another to see new listeners subscribing from India, Singapore, and the US in just the very first week. If you're new, please do check out our 5 earlier episodes at your convenience. They're absolutely bangers, if I may say so myself. Tell your friends, your colleagues, and your family members. Alright, let's get to the episode. Joining me and Praveen Gopal Krishnan, my co-host, are two very sharp leaders I've long had deep respect for. A quick disclosure, Kailash is the CTO of Zerodha. Zerodha operates an investment fund called Rainmatter Capital, which is one of the investors in the Ken.
Our first guest is Kailash Nath, who's the CTO of Zerodha. So, Kailash calls himself a hobbyist software developer and a tinkerer. He holds a BSc in computer science and a PhD in artificial intelligence and computational linguistics from Middlesex University in London. In 2013, he started the tech team at Zerodha, India's largest stockbroker, where he's been the CTO since. Kailash has been coding since 2000, starting with Perl and WB6.
VB6, Visual Basic 6, you have not been coding.
Yeah, I should just say that this is VB6 and not WB6. These days, he mostly writes program in Go, which is supposed to be a really cool programming language. So the reason why Kailash is here is, of course, big to talk about careers in engineers, etc. But I'm going to talk about Kailash's introduction through this one quote that he has written on his website. And here's the quote. I am fortunate to be in a position where what I do every day is exactly what I have unconditionally enjoyed doing for more than 24 years now. Writing software, tinkering, and experimenting. Welcome, Kailash.
Thank you.
Our second guest is Amod Malviya, co-founder of Udaan. Amod co-founded Udaan, India's most well-known B2B e-commerce platform. Prior to this, he was a CTO of Flipkart, India's largest B2C e-commerce platform. He's been in the tech industry since 2002 and with startups since 2004. Amod holds a B.Tech honors in electrical engineering from IIT Kharagpur. Though Amod dislikes labeling, he also says that the label that's likely to cause the least amount of controversy for him is an engineer. For the simple reason that it is a core part of who he is. For as long as he says he can remember, he's relished building things, tinkering with them. That's the second instance of tinkering from our guest. Fixing them. Be it professional, large-scale distributed systems or being the family's handyman. As lapsed engineers, both Praveen and I are thrilled to be joining these two practicing engineers today. Welcome, Amod, to the
Thanks,
show.
Rohan.
Engineering careers. I want to add a bracket around that and let's call it software engineering careers because engineering, much as we all talk about ourselves as engineers, is too vast. It's like an ocean for us to cover in just one podcast.
Yeah, we're not
So
going to
let's-
discuss building bridges today. So it's just software.
Engineering careers used to be a ladder. You studied for 4 years, you got a job as a fresher, and you could virtually take for granted a steady career filled with learning, hikes, and work. In fact, being an engineer was so cool that we made fun of the MBA types, the suits, for their inability to find a tech co-founder. Right? We'd see these suits hanging around at startup events, asking people, would you be my tech co-founder? And we found that really funny. I mean, I've been there. Because, of course, while ideas, business plans, and marketing skills were commodity, apparently, writing code and shipping products wasn't. Except, that's not increasingly true. Just today, I was reading a New York Times story, which is published today, 19th August. It features Professor Sean Ammirati, who's been teaching a class on entrepreneurship for over a decade at the Carnegie Mellon University. I quote from the story. I have a pretty good sense, this is Professor Ammirati speaking, I have a pretty good sense how fast the progress that students should make in a semester should be, he said. In 14 years, I've never seen students make the kind of progress that they made this year. And he knew exactly why that was the case. For the first time, Mr. Ammirati had encouraged his students to use generative artificial intelligence as part of their process. Quote, think of generative AI as your co-founder, he recalled telling them.
I just want to say that nothing that we're going to discuss today is more terrifying than the idea of having a technical co-founder who is AI. We have already seen a lot of, maybe Reddit and Hacker News threads where people are talking about how AI chatbots are capable of writing code. We understand that that's not exactly what they're doing, but we'll come to that. But the fact remains, so what does this mean? Is this the end of the era of engineers? Are we staring at this time where your technical co-founder is going to be an AI? Kailash, strong points of views around this?
I think you said it's a very terrifying thought, but I think it's not as terrifying as having an AI as a romantic partner. Apparently, that's also really happening at a very large scale.
Engineers are very busy. Yeah, go on.
So wait a minute. So you're saying that finding a technical co-founder who happens to be an AI is less bad than finding a life partner who happens to be an AI? I think we can all agree on that.
I can't comment on that. But I think the word co-founder here in this context, it's too strong a word. What does that even mean? And I think, so there's a lot of misconception, there's a lot of craze happening, there's a lot of hype, there's a lot of excitement, and there's a lot of legitimate breakthroughs here. I personally have been using some of these LLMs to improve my workflows. And as an engineer, as a developer, an experienced one at that, I've been saving humongous amounts of time. But if you think of a young person who's just starting out, who's learning, the way they would use some of these tools, it's going to be extremely different from, let's say, a seasoned veteran. So you can always go to an LLM and bounce off of your business idea with the model, and it'll give you very convincing and sometimes insight-inducing responses. But
and complete code. You could give so many LLMs
to a reasonable extent. As things stand today, we're talking about breakthroughs that have developed over the last, let's say, 24 months in their current form. This is not like a 5-year-old thing. These technologies have been around, but all of this is centered around 24 months of breakthroughs and innovation, right? I don't think these models are in a state where they can generate an entire business idea as a technology product and give it to a business co-founder where they can run with it and make a viable technology business out of it. Now, it might get there over a period of time, but right now it's not that. So there's a lot of frenzy. And you can ask an LLM anything. It will give you very viable looking answers. And it will also give you sometimes deeply insightful answers. But does that suddenly make you or enhance you as a business co-founder to make a viable startup or a product? It's unlikely.
So, Amod, if I were to ask you, has AI made software engineers much less powerful or unique because of their ability to write code or ship products? What's your views on it?
I think the answer would vary based on who you ask that question. In my view, to have a conversation about it, we need to define engineering a little better. Otherwise, we will keep talking about different things.
Define it.
I'll go back. I know that, you mentioned that we shouldn't bring in bridge building into the picture, but I'm going to use that analogy, right? Let's say a person knows how to lay bricks. So bricklaying requires a certain amount of training, okay? Versus building a bridge. Are these two identical activities in terms of the skill needed, the ability needed, and the kind of understanding you need to have about systems? Bricklaying is what I would map to programming. The bridge building a bridge, designing a bridge, characterizing its parameters, those are things which I would associate to engineering. And
so interesting. So for you, programming is a subset of engineering.
It's the least interesting part of what I would say as engineering systems. Now, I don't mean to say that it's not fun. Like for me personally, and I'm sure Kailash would agree as well, it's deeply therapeutic. To actually, for example, let's take journalism. Writing would be therapeutic to some of you, I'm sure. And
I'll agree to that.
Yeah.
And I'm sure Praveen
Right?
will.
And
also.
yet, writing on its own would not constitute the core essence of what makes you a journalist. Right? It's bringing together very varied pieces of information, a little bit of investigative, techniques and whatever. A lot of things come together to actually create a great output. And it's a similar story that actually plays out in software engineering as well. To build a product is way more than just writing a program. And that is, it's a discussion that has become very colored and very polluted over the past 10, 15 years, I would say. Because what has happened is a lot of accessibility came into technology. Programming languages became very accessible. You didn't actually need to understand how computers work in order to be
In fact,
productive.
you didn't even need to write code because there were no code.
Yeah, right.
No
So a lot of
yeah.
those things have actually started happening. And what initially it feels like to a non-technical person, it actually feels like my so-called technical co-founder is actually there for programming, right? And we used to laugh at the suits back then. And similarly, this idea is very laughable right now that engineering is equal to programming. What tends to happen is because people outside of technology view software engineering as programming, they get so excited when they see an LLM produce code. Okay? When in pretty much all of my circle, direct and indirect, like every engineer I see is actually super excited about it instead of actually having some sort of an existential crisis. It's actually the exact opposite. What Kailash was talking earlier about, this leading to huge improvements in his personal workflows. Every engineer I speak to is actually super excited about it. Absolutely none of them are even in their wildest dreams are actually worried about being replaced. And yes, I'm aware about a lot of essays online, which a few 25-year-olds have written about how they are going to,
I love how Gen Zs are always wrong about everything. I'm just sorry.
I certainly don't want to come
joke.
across as that generational, standard generational, crib thing.
But sorry, Amod, before you go deeper, you seem to be making a very fundamental distinction between a programmer and an engineer. Could I ask you to define that for me? Because I'm not sure everybody, me included, is very clear what the distinction between a programmer and an engineer is.
Fair enough. So,
especially in the context of, let's say, software.
Fair enough. So I'm going to give it a shot. I will encourage, though, for anybody listening to this podcast to go through an essay by a person called Jeanette M. Wing. The essay is called Computational Thinking. The idea is programming at its most basic is telling a computer what to do. Okay? You've already planned out, the logic behind it is the core intelligence piece of it. Okay? That happens before you start programming, before you sit and actually start writing out those words, those nouns and verbs that actually then gets compiled into a program. That activity is what I mean by programming. Obviously, there are varied definitions of it, but in the context of this discussion, when I speak about programming versus engineering, this is what I mean by programming. For different kinds of jobs, you run with different kind of languages. For example, for some kinds of languages, Go is actually a much better option, whereas for some other scenarios, JavaScript would actually, or TypeScript would actually be a much better option. A programming language is a way to tell a computer what to do. But how you model the problem, how you think about deconstructing the problem, analyzing it, making it subject to computational tractability. That is where the interesting magic really happens in software engineering. It happens in how different components in your system interact with each other, such as, on a more technical level, for example, how two different nodes in a distributed system sort of interact with each other in under high performance loads, etc. It could also translate into business logic. For example, a classic example that I like to use is that of a warehousing system. For example, in a warehouse setup, you've got this inwarding area, outwarding area, and a bunch of storage areas, right? These are humans walking to fetch a good and bringing it back, right? Does this remind you of something in computational analogy?
It just looks like bits and
Bytes and
gates
bytes essentially
and logic
moving
gates,
from one
yeah.
place to another, right? There is latency involved, there is throughput involved. Okay, you can build a warehousing system that doesn't understand the location of where a product is kept, so let's compare that kind of a system with another system which understands the location and the cost of traversing a certain distance. Okay, the first system, you cannot model latency and throughput of your goods, which means that you'll have a dumb warehousing system. In the other scenario, you have the ability to create intelligence. In the first scenario, intelligence is not viable at all. Okay, a lot of this kind of logic. This is what I mean by computational tractability. You've made a real world problem into a computationally tractable problem. This is where a lot of the real magic of software engineering lies.
I want to ask both of you. We discussed the evolving, Amod, you also helped us put together this chart of, if you look at the evolving technologies and what changed in the last 10 to 15 years, right? Like, the coming together of mobile, cloud infrastructure, GitHub, big data, JavaScript, etc. All of this, Node.js, NPM, etc. contributed to a massive rise in availability of technologies, ease of deploying it, etc. and stuff like that. From where I'm sitting, again, as a layperson, it looks like there is some sort of a rapid collapse, right? Because now one collapse is being triggered by AI, where you can now deploy all of these, some of these, etc., without having a lot of knowledge about it. The second collapse is the disappearance of zero interest rate phenomena funding, which means now if you are a founder and you raise X million dollars, you will not hire 100 engineers because you cannot afford to hire 100 engineers because the money just isn't available, right? The third aspect, which is the most interesting thing, is that new technologies seem to be coming up. If these are the technologies that defined the last 10 to 15 years, what will define the next maybe 5 to 10 years? 15 is too much. How do you see, both of you see, how technology will evolve over the next 5 years?
See, a bunch of thoughts come to mind. Firstly, I would disagree on the point about capital. That lesser capital availability would mean that people would be
more efficient.
I strongly disagree with that. I think
because you're saying it's a habit. It's not unlearned
quickly.
Quickly.
It's a behavior thing stemming from lack of deep understanding of creative processes. I don't think those things change much. A peer pressure kind of a thing might drive some change, but that's a separate matter than the capital point that you were talking about. In terms of the path ahead, I think firstly, a few changes that are already happening. One is that a lot of the low-hanging fruits have already been taken up, right? Low-hanging fruits are those, where simply because smartphones came into existence, fairly recently, relatively speaking, and a whole bunch of companies immediately went out to have an app for every single thing, the ROI on that effort is getting lower and lower, right? So the law of diminishing returns is hitting very strongly. So that is one factor that is coming up. The second factor is, given that people will be forced to start thinking about more relevant problems, the threshold for putting a product out there is going to become higher. The quality of ideas becoming better, I feel, would happen the most in areas that sit at the conjunction of different disciplines. Okay, so whether you think about computational medicine, whether you think about the personal productivity being completely rethought out, in each one of these areas, the biggest movement would be done by those who can wear multiple hats of different domains, on the same head.
What does this mean from a technical point of view?
From a technical point of view, what this means is
either programming languages or paradigms or I don't know, structures, distributed systems. What kind of technology waves or trends can we hope to see over the next 5 years?
Okay, so let me use an example to highlight, the point, because I don't think I can generalize that in a good enough way. There is a company, and full disclosure, I'm an investor in that company. It's a company called Tiger Beetle. Okay, but the T-shirt that you see me wearing is a conference that was actually organized by them a couple of years back. As a database, they're a database company. Now, the concept of databases have been in existence for a very, very long time. But what has happened is that computer architecture has gone through a significant change over the past 20 years. Okay, the bottlenecks have essentially moved significantly. You guys would remember how slow disks used to be, and a lot of the intelligence in databases used to be how things are laid out on the disk, so that one sector can be accessed immediately after the other. So a lot of that sort of intelligence actually used to be built out into the databases. In the current scenario, we have networks that are faster than the memory. Okay, so memory is actually the bottleneck. Okay, we have completely new protocols. There's all computers have almost all computers currently use a bus called PCI Express link. Actually, not technically a bus. PCI 5.0 actually brings in the notion of CXL, which has some very interesting implications of how information is put onto the cache of a CPU instead of actually being put on memory. Now, when you think about a lot of these technologies coming in, and I'm using just one example, there are many such examples. The way you think about a lot of your database architecture has to be completely rethought. Okay, so this company, Tiger Beetle that I was talking about, is taking a complete full stack look at how database should be architected. They're bypassing the kernel, talking to the disks directly. They're using full use of the much larger queue depths that exist in the NVMe protocol. Their storage safety model doesn't rely on the operating system telling you that yes, I have saved this file. They don't rely on the OS telling them that I've saved this file means the file is safe now. They use their own methods. So a lot of things like these we'll actually start seeing a lot more of.
But speaking of paradigm, Amod and I, on the way here, we had a very interesting discussion about decentralized discovery of content. The basic premise was that classical internet that many of us, I don't know, from way back really liked, it's gone.
It's been centralized now.
Everything is heavily centralized. All the publishing platforms, social networks have taken over the World Wide Web. This is boomer talk, but still, there's reality here. And the quality of content, the incentives that lead to the production of content, etc., are completely skewed. And especially with the advent of LLMs, the internet is going to be filled with absolute garbage that looks
slop.
legitimate.
There's a word for it. Slop. AI slop.
Oh, slop.
That's what it's called.
Yeah. So that's the reality. And we are, I think, heading towards the peak of the cycle where there's going to be general resistance. It won't happen overnight. It'll happen slowly over the next few years. Resistance towards some of this massive centralization and the amount of garbage that is being pushed. It's the same gatekeepers of the World Wide Web or the internet who are pushing garbage out for obvious financial incentives, right? So the concept of decentralization, which is nothing new at all, the very internet is decentralized, I think will start re-emerging as a new paradigm in delivering consumer tech and software. Everything, there's always a pushback. People get sick of it. And here, objectively, things are getting worse. So I think there's going to be a pushback to more decentralized, federated.
So the thing that I find common and contrasting between what both of you said is that, Amod, your point was essentially that, look, the future of engineering is probably going to be changed by our notions of what scarcity means. Like in the traditional sense, maybe say processing speed was scarce, so you had to really innovate and use all your engineering prowess to use it very optimally. Now that has changed to maybe something else. Perhaps it's the usage of memory or database structures. So wherever there is scarcity or wherever there is bottlenecks, that is where the might of engineering ingenuity goes. So he's talking in lens of scarcity. You're talking through the lens of excess. You're saying that because now there is centralization, there is going to be excess, and this excess and surplus is generally poor quality, and so hence we are going to revert back in certain places towards federated systems that lead to removal of this surplus.
I think, let me enumerate two issues, okay, just to sort of bootstrap this conversation a little. One is the continuum from school to college. College doesn't happen in complete isolation of the schooling background, right? Our schools teach kids something and teach kids certain behaviors that maybe are not as relevant for college. Let's take predictability, as an example. In school, the goal is not to get educated. The goal is to get into the next class, because so long as you have cleared the exam, your objective is essentially met and you move into the next class, right? There is predictability. College time acts as that buffer between the real world and your, schooling system. And it's useful for us to apply that lens when evaluating what colleges actually do to the people today. And it also helps determine the behavior of students often enough in colleges. When kids enter college, the approach to education, particularly in engineering, needs to fundamentally go through a change, because it's a very it's not just a theoretical subject. You are actually expected to be building something. Okay, and that's the core essence of engineering, and that's what differentiates them from scientists, pure scientists. You've got to be building something. That idea of learning something to be applying in the real world is so disconnected from the schooling background that most kids actually go through. It's miraculous that the people actually still survive the engineering curriculum. Okay. In order to make that journey easy enough for the students, colleges often end up dumbing down or changing their curriculum, the method of teaching, all of these things to better suit for that continuum, that jump from the schooling to college, than preparing the kids for college to real life. That is one observation that I've had. Okay, that if you look at...
so you're saying that there are two chasms. One is between school to college and the other one is between college to job.
Yes.
And you're saying colleges tend to focus more on bridging the initial chasm rather than the other one.
100%. That's precisely what I mean to say. And the simple reason for that is that's the only chasm that people have experienced until then. The second issue is that of labels. And at the beginning of this conversation, you'd mentioned my hatred for labels. What that does is it boxes people's minds. You are a civil engineer, you are a computer engineer, you are an electrical engineer. It boxes people's minds, and it actually takes people away from the underlying homogeneity of knowledge. There's a brilliant book by one of the greats in our field, Richard Hamming, called The Art of Doing Science and Engineering. And he talks about this so brilliantly that, we've got to eliminate these labels. In the presence of these, we tend to be way too narrowly focused, and we over-index on the tools to be used in such and such field instead of thinking about generalized engineering principles. A lot of engineering has very common foundation in very specific kinds of mathematics. Okay, how we model systems, how we characterize these systems, civil engineer, electrical engineer, mechanic, the huge amount of commonalities. And a lot of these same principles also carry over to the computer sciences, for example. But the moment we label kids as you are this kind of a discipline of engineering, the whole culture within that department, the way people think, would you believe people think about programming as a computer science thing? Now tell me, do you think about arithmetic, like counting plus minus? Do you think that as a mathematician thing? Or do you think about that as a common human knowledge base, which is, pervasively useful? Programming is like that. For engineering, I mean. There's absolutely no branch of engineering where people shouldn't be taught programming or computational thinking for that matter.
Yeah.
Okay, so these artificial distinctions.
Have you seen this? This is a very interesting point that you're making. Are you seeing this change in any of the colleges in India or that impart engineering education, including some of the newer ones that have come up?
So I'm seeing some attempts of this. How these attempts pan out is something that only time will tell. But at least I'm seeing acknowledgement of this issue. And I'm seeing some degree of intent from this. I'm seeing particularly in the newer, the new age colleges, without naming them. At IITs, for example, at least I can speak for Kharagpur, there are some newer departments that are actually being set up due to the initiative of some of the professors who acknowledge this problem. So there are attempts being made to move in this direction. We'll have to see how this pans out.
I think that brings us to the most pertinent question of scale in India. Everything is supersized. How many great universities can you have, right? How many professors will have to set up schools or branches that will impart the right kind of engineering education? To answer your question, are we seeing a change? I've come across maybe 3 universities who are trying radically different programs, combining humanities and critical thinking and philosophy as branches right before they enter engineering. Now, I found that to be very interesting. But how many students will they each take every year? I don't know, maybe a few hundred. So the problem is basically of scale.
But that's such an interesting thing in terms of getting kids ready for a very different mindset than what probably they have gone through in college.
Exactly.
Yeah, but I think that was the thing that I was going to ask about. Does imparting humanities into engineering education make a difference, or do you foresee it making it? But you already brought it up unprompted. What possible, second order, third order effects do you anticipate?
Huge.
Do you think they'll be much more receptive to some of the ideas and notions that you put forward? For instance, that you spoke about, say, the notion of federated versus unfederated system. Maybe a humanities perspective about how these things change.
And huge. I think it's been a blunder that a human-centric or humanities. I mean, I know that humanities is a vast spectrum in itself, but you know what I mean. That should have been a part of many engineering curriculums to begin with. I think especially software, because the people who come out and build systems that affect billions of lives, we make fun of ad companies now. Search companies are now ad companies, etc. Right? We even have a term for it: surveillance capitalism. We have massive surveillance. We have huge intrusion into privacy. But these are all being built by brilliant software programmers, developers, and engineers. And often when you are from within the system, you don't even realize that your piece of work in the vast machinery, what its implications are. I retrospect a lot and think of my own work, and I don't really have answers. But unless you have a very human-centric approach to building software systems and deploying, you'll most likely end up veering towards techno-solutionism, which is very rampant.
Yeah.
There's a tech solution for every human problem. Scan this QR code, you get an OTP, your life is sorted as a citizen. That is an absolute lack of empathy for humanity, society, and age-old conventions of what it means to function in a society. Ideas of liberty, freedom, everything. And this is why, Silicon Valley is now cited as a classic example of textbook techno villainy. Crazy, right? It used to be a place of hope. Utopia. But what's happened to it now? I think this should have been there from day one. And like every again, human endeavor has a tipping point. Maybe we'll eventually, over the next few decades, go back to this. But my point was, I've
I
come
think
across...
that tipping point has a name. Elon Musk. Hi, this is Rohin. You're listening to an edited and truncated version of 2x2. Unlike earlier free episodes, it's not the first 30 minutes of the discussion, as you must have realized by now. The full version of this episode is nearly 3 times the length and available exclusively via the Ken's apps to our premium subscribers or on Apple Podcasts with just a monthly subscription. But we do value you as a listener even if you don't want to subscribe to the Ken just yet. Please do stay a free subscriber. We will be adding more features for you too. FYI, you can also read a newsletter version of this episode written by me on the Ken's website this Friday. Sign up for it for free using the link in the show notes. See you next week.